Good afternoon, everybody. I'm just going to give people a few minutes to join, because I see it's only Santa people that are here for now. So maybe give people 2 minutes or so to see if we have more attendees. Good afternoon, everybody. Again, we are just starting a little bit late to see if more people will join our webinar today. So we will start definitely by 5 minutes past 2. Good afternoon, everybody. Thank you for attending today's webinar. This is Science's second webinar for this week in a series of 5 webinars. The webinars are celebrating the World Space Week, which has a theme of celebrating women in space. So our webinar series, at the end of, at each webinar, we will pose a question which we ask that participant answer to by sending the 5 answers. So at the end of the week, you send all your 5 answers to the question posed at the webinars at the email address that will be given to the in the chat box right now. So today's webinar is Meet Space Weather Forecasters, forecasting space weather to protect technology. We will have a panelist consisting of the four space weather forecasters. The first one is Nkosinathi Masango, who is from Soshangube in Pretoria. She obtained an honors degree in meteorology at the University of Pretoria in 2019. Thereafter, she practiced as an operational weather forecaster at the South African Weather Service for a few months in 2020-2021 before joining SANTA in Hermanus as a space weather forecaster in June 2021. So over to you, Nkosinathi.
Good afternoon, everybody. I hope you can see my screen. I'm unsure if you can see it or what. I just need somebody to say that they can see it.
Yes, we can see it. Thank you.
Okay, thank you. As Zama introduced me, my name is Nkosinathi Masango, and today I will be explaining how I moved from practicing how to forecast for terrestrial weather to space weather forecasting. So I hope you enjoy my presentation. Okay, so first and foremost, my interest in science, I'll start to explain to you how I became interested in meteorology. So from a young age, I didn't understand, when I was taught in primary, I didn't understand how can it be possible that we live in the same world, but one half of the world is sleeping while the other half is still, waking. For me, it was supposed to be uniform. We should all sleep at the same time or eat at the same time. Everything must have consistency. So I couldn't understand that. And then my primary school teacher explained to me that, no, actually, the Earth orbits around the sun. So that's why we have that. And then I went to a school where I had to further my studies in high school. So the problem was that they taught in Afrikaans. So I had to teach myself Afrikaans so that I can learn the language. So the easiest way of doing this was to look at the news. That's when my curiosity started there. From that day onwards, I wondered, how did they know that it's gonna rain? How did they know that it's going to be sunny or cold? So I guess it was something that really interested me. And then my high school teacher told me that I can actually study the atmosphere. And then to my surprise, when I went to varsity, I actually realized that we can study what we call meteorology. So basically meteorology, for me, how I explain it, you are just studying a chaotic system on a professional scale. That is because they say that the atmosphere is a very chaotic system. So that's when I went to the University of Pretoria and I studied it. And then at the weather service for 10 months, I was trained to become a weather forecaster, and I trained in the public, marine, and aviation disciplines. So after 10 months, I was qualified to practice as either a public, marine, or an aviation forecaster. But then I discovered something new, which was space weather, where I applied, and now I'm here. So I'm just gonna take you through in simple terms, what is space weather? So basically space weather describes like the events that occur in space, which can influence the space environment and the functionality of your spaceborne or ground-based technological systems. So basically the activities that happen in space, or if I can say that occurs on the sun, they affect our technology. So now that we have established what is space weather, we now need to find out what exactly is the problem, because as human beings, we usually like to solve problems. So the problem is that space weather can negatively impact numerous sectors that depend on technology. And as you know, how time has evolved, technology is the key driver. We can say the key driver to an economic growth. So the problem now is this space weather affects our technology, and technology drives our economic growth. So now, since we have established this problem, now we can say, why should we care? So first and foremost reason why we should care, all these solar activities that occur on the sun, we have, for example, your solar flare, your coronal mass ejection. These solar activities, they result in space weather. So they affect different sectors. So the first sector, we call it, is the geomagnetically induced currents, shortly known as the GICs. So it arises from a geomagnetic storm. So if same way that we have thunderstorms here on Earth, we can simply say thunderstorms there by the sun. So they result because of these extreme solar activities. So what happens now is after you have these geomagnetic storms, they cause saturation of transformers and they increase current. So basically, if you have like your transformer, now the voltage in your transformer is going to increase. Now, if it increases, remember that there's a threshold in how they build your transformers are built. So it has extra current in it, which can now turn it to damage the transformer or burn it out. So it actually burns the conductors that are in there. So that's one of the first impacts that it has. And that is a problem because we use electricity, we use power utilities to drive our economic sector. So businesses might close down because they do not have electricity. So we need to prepare for this also. The second one would be your communication and navigation network. Most of our communication and navigation network, they depend on the satellite system which orbit the sun. So when you have these solar flares or this coronal mass ejection, they could damage your satellite system. So they can damage the outer parts of your satellite system, or they could, what happens is when you have these things, we have there's a layer we call that it's the ionosphere. So what happens there, if there's too much interruption in your layer, you could lose your satellite signal, which can lead to inaccurate positioning and timing of your GPS coordinates or of what you are tracking. You could lose track of, your coordinates of what you've been tracking. And that can be used by stock markets, the banks, they can also use that. That can also affect us. So that's one aspect that we should look at to be interested in. And then the other one is your transport. What happens is most of your transport, especially in aviation, they use what we call HF communications. That's your high frequency radio channels for communication. So when you have these space weather events that happen, there's an absorption of these high frequency radio waves during these solar activities. And if you have an absorption of that, now the wavelength that they use at that specific channel, they have to either fluctuate or change it. So it can disrupt your transportation system through the impacts that they lost their navigation and control system through this absorption of frequency radio waves. So that could lead to your flight delays and rerouting. So that is the problem of one issue that we should look at and how it affects us. And most of things is done through transportation. It's not necessarily aviation. It can also affect your railway systems. That's also another mode of transport where a lot of goods and services are being transported through using those railway systems, or also aviation. So what am I doing now? Currently, I'm in training. And what is done in training, they teach me they train me how to be able to monitor these activities so that we can issue warnings in time and be able to prepare the public for what might occur. So this is technically what we do. We look at, like you can see here, we have our sunspots where most of these activity happen. So when on your sun, you'd have what we call sunspots. That's when you see these sunspots, that's when you should be alerted that we might have these activities. We look at your coronal mass ejections using different instrumentation and observation. And space weather is not so bad at all. Those who are fortunate enough, it does show some fascinating lights, which they call them the northern and southern lights. So these are auroras. They're not harmful. They're just beautiful to watch. So it's not so bad, I guess, out there. And then something that I like doing, I like entertaining people. Besides being a forecaster, I'm not a boring person. Well, that's what I'd like to believe. So I want to take you through a quick video. I hope you can hear these videos of life as a forecaster. How is my life as a forecaster? So let's take a typical example. Let's say the previous night you submitted your forecast, and in the morning you wake up and you check all your observations and data. And this is how you feel when everything is still under control. And then you are so excited to go back to work. You are a happy person, so you do your victory dance during lunchtime because everything is still under control according to you. Your forecast is following observation. So and then once you get to work and you're still there, when your forecast starts falling apart, this is what normally happens, something that the public never sees. Your colleagues are also just as shocked as you are, and you also don't know what's happening, and it's quite frustrating at some point. So this is what would normally happen to you. And then after that, now you go home and you are not so impressed about your work, the work that you put out there into the public, and you go on Twitter, you go on social media, Twitter, Facebook, Instagram, and the public, they give their own opinions. Some members of the public think they can do a better forecasting job than you, and when the best thing to do is to ignore all those emails, all those WhatsApp, all those Instagrams, and this is what you just normally do. And when you get to work the following day after and you check what really happened through observations, because we actually do verify our forecast, we do check where we went wrong so that we can improve our models. You must remember that when you focus something, you don't only rely on observation, we do have models where we look and try to see how we can improve those models. So when you go through your verification documents and all of that, that's the last reaction that you'd have as a forecaster, because as much as you are shocked why I got it wrong, I also get shocked why sometimes I tend to not get it. And yes, that was my presentation to give you an overview of the technological impacts that space weather has for us, and I hope you did enjoy it. My final words to those who are listening: I believe that you are free to choose, but you are not free from the consequences of your choice. The second one is that success is your own responsibility. People are just there to guide and support you, nothing more, nothing less. And lastly, good luck to all of us, to those who have things to do. We wish you all the best. I hope you enjoyed my presentation as much as I did, and I'll show a bit of myself because I think I didn't share my video. And yeah, thank you. So any questions, I'll try to answer. I do not have the answers to everything, but I'll try. Thank you.
Thank you, Nkosinathi, for the insights in your journey towards being Santa's space weather forecaster. If questions, if they can just pose the question on the chat box there, then at the end of the webinar, after everyone has presented, then we will pose the questions. If possible, then you can just say who the question that you have is addressed to. So if you have for Nkosinathi, you could say question for Nkosinathi and then your question. What I forgot to do in the beginning of the webinar was actually to post or to say what the question for today is. So the question for today is, when did the forecasters commence their training? I'm sure each of them will actually give you the date. So if you listen very carefully, you note down the date. And then at the end of the week, you collect all your answers to from the other webinars, and then you email them to the email that is given in the chat box. So with further ado, the next forecaster that will be presenting today is Kaki Leshivambu. We don't know if she's related to the EFF Shivambu, but I'll leave that for the people. She is from Limpopo in a village called Hinga in Malamulele, Northeast. She obtained her honors degree in meteorology, also from the University of Pretoria in 2019, and then trained as an operational weather forecasters at SOURCE for a few months before joining SANSA Space Science in June 2021 as a space weather forecaster. So Katekile, over to you.
Thank you, Zama. Can you hear me?
Yes, you can.
Okay. Oh, thank you. Let me give you a brief description of my journey to becoming a space weather forecaster. Just to share a bit about myself, Zama already introduced me. My name is Kaki Leshivambu. And yes, all the Shivambus are related. I'm 26 years old and I'm from a village called Minga. It's located in Limpopo in the northern parts inside Guyana. So my interest in weather started about 19 years ago. That is an 8-year-old me standing by the window watching the rain. I was so fascinated by the rain as a child. I used to wonder, why does it rain on my birthday? Why the following day it doesn't? So I grew up with that obsession, watching the rain, drawing the clouds and observing the atmosphere. And then when I was doing grade 8, my older sister went to university, and when she came back for the first holiday, she told me that there's actually a course called meteorology where you can study the weather. So I got so excited. When I completed my matric in 2012, I went to the University of Pretoria, where I completed my degree and honors degree in meteorology. So if you can see that there's a bit of a gap between 2012 and 2019. It took me about 7 years to complete my honors degree, including honors. That's about 4 years, but it took me about 7 years. So there was 3 extra years. I struggled a bit with mathematics. I think I should share that with everyone. It was a bit of a tough journey there, but I finally made it. I became resilient and I made it to my honors degree in 2019. In 2020, I did my aviation forecasting and weather forecasting training at the South African Weather Service. And I also worked there for a few months, like Zama already said. So currently, I'm a space weather forecaster in training. The training period started on the 1st of June, 2021, and we're expecting it to end sometime early next year when we're gonna start being operational. Our job as a space weather forecaster will be to analyze, monitor, predict, and forecast the space environment, and also issue warnings and alerts to the public and our clients, and also to inform people how a space weather can affect our technological systems. So we're going to be doing that on a 24/7 basis. So I also wanted to share the people that visited our facilities this week. They could have seen the construction outside. This is how we're expecting it to look like, and we're looking forward to moving in there. This is where the new Space Science Center will be. So the picture here, at the top here, where you see me here, is the current Space Weather Center. I just wanted to show you how it looks like if you haven't visited us. So as a space weather forecaster, I'll be monitoring the behavior of the sun. So the picture here at the bottom is one of the images of the sun. So on this slide, just wanted to share that my interest from it as a child, it was mostly on the troposphere layer, where I was more interested in the clouds. But when I joined SANSA, I learned about the layers at the top, which I didn't even know they exist, or I did, but I didn't know that there was something more interesting that is happening there. So now the space weather forecast, I'm getting to learn more about what's happening in the thermosphere, which is 600 kilometers above the Earth. So Nkosinathi has already introduced what space weather is, so I won't waste time on that. I'll just talk about some of the space weather impacts that we have. So I'm more interested in the auroras, so that's what I'll be talking about. Okay. So the auroras are a result of the collisions that occurs between the solar wind particles and the atmospheric gases. From the image here at the bottom, I hope you can see my my cursor. You can see the sun and there's the Earth. We have a solar wind. So when solar wind interacts with the Earth's magnetic field, the Earth has a magnetic field, and we refer to that as some sort of a shield that protects the Earth from the solar energetic particles from the sun. So when those solar energetic particles interact with these magnetic fields, they move through the magnetic fields into the Earth. So there they get to interact with the atmospheric gases, such as oxygen and nitrogen. So what happens is when these solar energetic particles interact with oxygen molecules, they get to glow and shows these beautiful colors. So if it's in oxygen, it shows green or red lights. If it's nitrogen, it shows it gets to display blue or purple lights. So this is a picture of just a picture of the auroras. So they occur along the poles. So over the northern poles, we call them northern lights or aurora borealis, and over the southern pole, they call them aurora australis. I prefer the southern lights, much easier to say. So on this image here, I just wanted to show you how they get to glow into these beautiful colors. When the energetic particles interact with an oxygen atom above 200 kilometers, it glows red. But if it's between 100 kilometers and 200 kilometers, when they interact with an oxygen, with a nitrogen atom, they glow blue. And if the same the secondary electrons get to hit oxygen atoms, they get to glow into a green color. And then below 100 kilometers, which are also above 85 kilometers, when they interact with nitrogen, they glow into this crimson color, but I prefer to call it purple. So auroras, they occur with solar energetic particles, but when they become more enhanced, when we have geomagnetic storms. Geomagnetic storms occurs when there's a wind shock that occurs from a CME interacting with the Earth. So from the bottom image that I'm pointing at here, you can see there's an aurora being injected, and you also get to see the Earth. So we have this, there's this layer that is around the Earth. So when it interacts with that layer, it creates this shock. So that's what we call a geomagnetic storm. So that with a geomagnetic storm, it gets to enhance the auroral oval. And auroral oval is a region where the auroras occur along the poles. So this is an auroral forecast. This is for today. This is the forecast for the aurora for today. So the image at the bottom, this is just a model of a CME in being ejected and interacting with the Earth. So just to say some goodbye words, I would say every storm in your life is followed by a rainbow. I'm saying that in the sense that it took me a very long time to complete my degree, but I was resilient, and beside the storm that I was facing, struggling with mathematics, I was more focused on the prize, which is the end of my degree. So I think that's all I have for you today. Thank you.
Thank you, Kaki for your very interesting presentation. The next panelist is Boitumelo Makobe, who is from Mamelodi in Pretoria. She also completed her honors degree in meteorology from the University of Pretoria in 2019 and obtained a postgraduate certificate in weather forecasting in 2020. She is now currently one of our space weather forecasters at SANSA in Hermanus as of June 2021. Over to you, Boitumelo.
I can't share my screen. Katekile, can you please unshare yours? Thank you. Hi everyone, my name is Boitumelo Makobe. I hope you can see my screen. Can all of you see my screen?
Yeah.
Okay. So as Zama has introduced me, I am one of the 4 space weather forecasters. I'm 23 years of age and I'm from Mamelodi. So I'll be taking you through a journey of how I got introduced into science and how I journeyed through my academic journey into also being into forecasting, terrestrial weather forecasting, and also space weather forecasting. So okay, so just a little bit about myself. The image that you see here is the Major Jamison reading room. So basically this is where I spent 2 years of my high school, most of the time. So this is a mini library. It was also a mini science center. So they would hold seminars every Friday and would go there to get help with homework and do our assignments there, because at the time I didn't have a laptop. So we would just spend most of our times there. So as you can see on the 3rd image, you can see some of the illustrations there. So this kind of reminded me of the science center that we also have here at Hermanus. So I was like, yo, this is like really amazing, because I used to spend my time here. So it constituted a lot to igniting my curiosity and me wanting to learn more about scientific things. Okay, so here is an image of me and a lady that I would say inspired me quite a lot. Her name is May Jamison. So I wanted to know why the reading room was named May Jamison. So I asked one of the tutors and he told me that I must just go and research who May Jamison is. I went and I looked and I found out that she's the first Black woman to become an astronaut, the first Black woman to actually go to space. So I was like, wow, this is really amazing. I really need to know more about this woman. Another fact that kind of like got me so excited was the fact that she was also born on the same day as me, which is the 17th of October. And I was like, no, I really want to know more about this woman. Through the reading, I realized that she had a book, and I went and asked about the book. They told me that they do have a copy, so they gave me a personal one. So on the picture here is when I actually received the book. I was in grade 9. So one of the interesting stories that she told was when she was asked that, like, her whole class in elementary school was asked what they wanted to do. And, you know, words like police, men were flying around, a nurse were flying around. And she was like, I want to be an astronaut. And her teacher was like, no, you mean a nurse? And she's like, no, I don't want to be a nurse. I want to be a scientist. And during those times, it was like opportunities in science for women was like, they were very, very limited. So I really, really admired her boldness. And I'm like, I want to also be like this woman. I want to pursue a career in science. So I got to grade 10 and I really liked the geography. But most of all, I really liked the climatology section. I asked my teacher and I was like, is there a way that I can just like learn more about, you know, everything about the atmosphere, climate and all of that? And she was like, yeah, there is a degree at the University of Pretoria. You can just go and study that. I looked into it, you know, and, you know, it involved atmospheric science. And I was like, okay, let's just do this. And yeah, I went into it. And then after matric, that's when I started my BSc in 2016 for 3 years. Did at the University of Pretoria, continued to do my honors at also the University of Pretoria. And then after getting my honors, I did my postgrad certificate in weather forecasting at the South African Weather Service, which was quite intense. The training was very, very intense. We had to do a lot of data analysis. We had to do look into a lot of observations. You know, we were taught about weather systems, the kind of effects that they have, the impacts that they have, what goes into giving out an advisory and a warning, of which was very, very interesting. Also worked as an operational forecaster for a few months. And one of the interesting thing about that was that you actually had to get to live through your forecast, which was one of the exciting things. You get in the morning and do a forecast, and then boom, at in the afternoon, a thunderstorm develops and you're just like, oh, okay, this is my forecast, and I'm like living through it. So which was really, really interesting and very exciting to live through. So yeah, now I find myself being a space weather forecaster. So I must say the transition between terrestrial weather and space weather forecasting has been rather interesting to see, you know, because they both occur at very, very different levels. You have terrestrial weather occurring below 80 kilometers, and then you also have space weather occurring above 80 kilometers. So what space weather is, basically space weather is described as how the conditions on the sun, the ionosphere, the magnetosphere, the thermosphere can influence the performance and reliability of spaceborne weather, spaceborne and ground-based technological systems. As I've said, you have the ionosphere, which is above 80 kilometers, and then you also have the ionosphere, which is above 80 kilometers, which forms part of space weather. You have your stratosphere and troposphere, which is more your terrestrial weather. And then on this image here, you're able to see the sun, and you're also able to see the magnetosphere, which is also mentioned on the definition that we have. And you also have your solar wind, which is constant energetic particles and plasma that is released from the sun. Okay, so basically this is just an image of space weather in a nutshell. So you actually have your space weather events occurring over here, and you also have some of the impacts that might occur. So you have cosmic rays, you have your solar energetic protons, you have solar flares, you have CMEs, which are cloud of gas that is a cloud of plasma that is released from the sun and can actually reach the earth in about 4 days. Okay, so you also have single event upsets, and then so basically what all these events that I've mentioned, they can have an impact on your navigation systems, your GPS, you know, some of them can result in your geomagnetically induced currents, which one of my colleagues mentioned. Some of them can result in disturbances in HF radio, in HF communication, and then also auroral displays. Okay, so basically I'll be taking you through what a solar flare is and what the effects of a solar flare can be on HF communication. So basically, I could say this is my favorite event. So yeah, this is what I'll be taking you through. So just a bit of background before I explain what a solar flare is. So you have, on this yellow image, you have these dark spots that occur, you know, and they're darker than the surrounding areas. So basically these are called sunspots, and these areas are cooler than the surrounding areas, and then they have a very strong magnetic field. So these sunspots, basically on a sunspot, you can have a solar flare occurring, and then basically a solar flare, and on this image, you can see it's like a sudden brightening that occurs on the surface of the sun. So it's a sudden eruption of electromagnetic energy that is observed on the surface of the sun, and then it takes about 8 minutes to reach the Earth, and then the effect can last from a few minutes to about an hour. Okay, so I'm gonna now talk about the effect of like a solar flare on HF communication. So your solar flare can emit large amounts of X-rays that can cause rapid modification of your ionosphere. So the D region, because the ionosphere is actually divided into regions. You have your D region, your E region, F1 and F2 layers, and then with your D region being the less ionized layer. So the solar flare can result in the disturbance in the HF communication due to the ionization due to the D region being more ionized. So basically, in normal conditions, the D region in the ionosphere is very important with regards to high frequency communication, which is about from 3 to 30 megahertz. And then it reflects these frequencies, which makes long range communication possible. So some of the sectors that use high frequency communication is your marine, your aviation, and your military. And then, so basically this image here is an image that shows you the frequencies that are absorbed should you have like a solar flare in an event of a solar flare. So when you have like an intense solar flare, you have absorption of all of the frequencies, which means that there is absence of HF communication. So that could result in a blackout. Okay, so as I've mentioned, the intense ionization of the D region due to an intense solar event can result in HF radio signals being lost or degraded or completely absorbed. So that results in a radio blackout. So in case of a solar flare, it is very, very important that your commercial airlines try to organize their flight schedules according to what the forecast has said, based on the forecast, or have measures that are implemented should a solar flare occur. Because you get that the pilots will have to resort to satellite communication in case of a blackout, and then, or they'll have to resort to higher frequencies to use other higher frequencies that are not absorbed. So so if you have a blackout, there's no ground-based air traffic control radar over the poles and over the ocean, so there will be no communication whatsoever. So the air traffic control will not know how much apart the aircrafts are. So this might result in accidents. If I'm not sure if they do occur, but yes, that might result in that. So furthermore, without means of contacting the crew, air traffic control has no way of finding out whether there are deviations in the flight route or the flight path. So there's no communication between air traffic control and the pilot, of which may result in fatal accidents. Okay, so this is the Space Weather Center. You can see that some of the images that I've shown you are what are displayed on the image that I've just showed you. So you have the big screen that has all your observations, that has all your data from some of the instrumentation that Santa has. So what the Space Weather Center is responsible for, it's responsible for monitoring, forecasting, and prediction of space weather. So it disseminates space weather information to clients via the and the public via the website, SMSs, and fax. And then it also does space weather analysis and verification of forecast and prediction. Should maybe a forecast go wrong, or maybe there is a missed solar event, we also do a bit of verification. So you have data from satellite instrumentation. So that helps us to measure the main source of space weather conditions as well as the impacts. And then you also have data from ground-based instrumentation, it's data from ionosondes that looks into the ionosphere. You have neutron monitor, you have a magnetometer. So basically these ones, they give us data that measures the magnitude and the impact of space weather. Thank you.
Great, thank you, Boitumelo, for that very interesting presentation, and also that message that's it's good to follow your interest and your motivation, especially when you started so young with Mate Johnson. So our last space weather forecaster on the panel is Nondumiso Khumalo, who is a 25-year-old from Umlazi Township in KZN. She attended the University of KwaZulu-Natal, where she obtained her BSc degree in Applied Maths and Physics, and later obtained a BSc honors in Physics with a focus on astrophysics. She again also joined SANSA in Hermanus as a space weather forecaster in June 2021. Okay, over to you, Nondumiso.
Thank you so much, Dr. Katamzi, for that introduction. Okay, thank you so much for the opportunity to be speaking to you today. Okay, so I'll just start sharing my screen. Okay. Right. Okay, thank you so much. Okay, so today I'll be speaking to you about my journey into SANSA as a space weather forecaster. Okay, so before we get into it, just a brief background about me. As mentioned before, my name is Nondumiso Khumalo. Okay, I'm a space weather forecaster here at SANSA in the Western Cape in Hermanus. I was born and raised in Umlazi Township, which is in Durban, KZN. I attended Durban Girls Secondary, where I obtained my matric in 2014, and I did your subjects like your maths, your physics, your life science, accounting, isiZulu, English, and LO. So, as I mentioned, I am a space weather forecaster, but what does that even mean anyway, and what do we do? So, first of all, as mentioned previously, space weather is just the study and the monitoring of the conditions in space. So we refer to space as the position between the sun and the earth, and how these conditions in space affect the technological systems that we have here on Earth. So as mentioned before, in the previous slides, we saw that the sun is not really a beautiful thing that just keeps quiet or is just calm. It actually, up close, it is very rigorous, and a lot of things are happening there. So you find that it releases these this plasma, which can affect the earth and therefore affect the technological systems. So there's a lot of things going up there. So with this said, space weather forecasting really just deals with monitoring these activities on the sun, and how these activities can eventually impact the Earth, and also using specific models to find when these events will eventually reach the Earth, like your CMEs, as mentioned in the previous slide. So many people would like to know, okay, so if I want to become a forecaster, what do I need? So I think my three colleagues mentioned that they did meteorology. I think at the moment that's the closest, I think, degree, I think in South Africa, I'm sorry if I'm wrong, that is very closely related to forecasting. But I think you can also, as mentioned here, even if you have physics, maths, environmental sciences, geography, and even computer science, you can find yourself in this field. So yes, many skills can be applied into it. So just a brief background of my journey. So in 2015, I was admitted for a BSc at UKZN for physics and applied mathematics. In 2018, I graduated with that degree, and I enrolled for a BSc honors in a program called NASP, which is the National Astrophysics and Space Science Program, which is offered at the Westville campus at UKZN. Okay, so I think that was basically, I think, the first thing closest to space science that I've ever had in my previous years, because unfortunately, I didn't, so in this degree, you had to pick between astrophysics, furthering the degree with astrophysics as your major, or space science. So I chose astrophysics due to bursary topics and all. So yes, I chose astrophysics, not knowing that space science will be coming for me in the future. All right, so in 2019, I completed that honors degree, and I decided to further my studies, and I applied also for an MSc for applied mathematics at UKZN. I also, in that meantime, I participated in a vacation work project, which was offered at the CSIR between the June holidays and the December-January holidays. Okay, 2020, I continued my MSc. 2021, I applied this year in February, around February, I applied. I saw this post, okay, space weather forecaster. Oh, what is that? I don't know. But then people always say, even like, you must always broaden your opportunities. So if you see something that you think you can fit in or can apply for it, you should just go for it. Don't doubt it, just apply. So this is what I did. I just saw this post. I didn't know what space it was, but I saw this post. I was like, okay, let me try it. Click, it's physics, it requires physics. So okay, I have physics, click, let me apply. Little did I know, in June, the 1st of June, 2021, I was accepted, or I started my position as a space weather forecaster here at SANSA. So I was really grateful to God for that. And then currently, well, as my previous forecasters mentioned, we are still undergoing training, because some people always say that space weather forecasting is a skill learned on the job. So you can't actually like study forecasting. It's something you learn by doing. So this is what we're being trained in now. We've just been taught or trained to actually forecast whilst like doing it. Okay, and I'm still pursuing my MSc. I haven't completed. Hopefully I'll finish soon. Okay, so one of the topics for me that interests me in terms of space weather is realizing how actually we can impact our power grids. So as mentioned before, space weather can cause disturbances rather, that can cause our geomagnetic field, that is the Earth's magnetic field, to vary, and this can induce electric currents in power transmission systems on the ground. So as I think, as we remember from physics, a change in magnetic flux induces a current. So if you have the magnetic field of the Earth constantly just being changed, moving around, that causes an induced current, and these induced currents can lead to our power grids here, like your transformers in the power grid, to overheat. And if this happens, see, look at these images below, this was caused by space weather. So these GICs, geomagnetically induced currents, caused this damage. So you can see here at the top, this is the transformer, which belongs to the Public Service Electric and Gas Company in New Jersey, USA, which blew up during a solar storm in 1989. So I think it was very interesting for me to find that these things or these events have so much power that even though they're happening all the way up there, but they can actually cause impacts that are so detrimental to our systems here on Earth. And that can affect a lot of things, especially around this time when we depend so much on these systems that something like this can just happen. So it also brings back the fact that it's very important that we keep track and continue to monitor our space weather conditions out there. Okay, and this is also another one, which was a failure of a South African transformer, which was also damaged after the Halloween storm, the biggest storm, geomagnetic storm ever experienced in October 2003. So this is a global impact. So it doesn't impact a certain region. So it can affect any region at any time. So we should always have our eyes open. And okay, this is just a graph showing you the signature of a geomagnetic storm. So if you see this, okay, so this is the flux density given in nanoteslas and the time that it happened. So if you see here, there's a sudden dip in the magnetic field, and this dip just shows you that okay, now there's a geomagnetic storm. So these are really, really bad but interesting. Okay, so what I enjoy about my job. So one thing is that, oh my God, it involves science. I've always been a fan of science. Even with, as you saw in the first slide, or the first slide, yes. I mentioned the subjects I did in school. So I did your physics, your maths. So I was very passionate about science way, like even in high school, because I knew, even in high school, I knew that whatever degree I'm going to pursue in university will be science related. So I'm very grateful that now I'm in a science field. And also learning about something completely new, which is exciting. Space weather, I mentioned. I didn't know what space weather was, but I really am enjoying how every day is just a learning curve, relearning new things, and I'm being exposed to this new lovely field, and I'm really enjoying every day of it. And also, wow, my favorite, working along experts who are renowned in the field. This is very weird because sometimes, you know, when you look at people or experts in the field, you picture them very far from you, you know, it's like they're very distant from you. But I find it very surprising how even the people I used to look up to, I am with them in this particular institute. So yes, working along experts in the field is one of my favorites. Okay, and also our new 24/7 Regional Warning Center, Space Weather Center, which is the state-of-the-art building, which is just being constructed just outside our window, which will start operations next year. So that is amazing. We have a new building that will be totally just focused on space weather alone. So that would be amazing. And it has a 100-seater auditorium. We're going to have a new control center with all these amazing screens where you see the sun's activities, and we have sleeping pods because it is 24/7 and we're going to be working at night. So maybe if you want like a small deep dip of sleep, you can just go there for a bit. Yes, and also one thing I really learned after getting the job is that actually we will be the first space weather forecasters in South Africa. I didn't expect this, so it was amazing to learn that this was the case, and also having to be along with these young Black women too. I think it's one of the remarkable things that I found out. So I'm very grateful to be part of this initiative. And I really hope and pray that everything will go just as great as it has been going now. And yes, and just a sneak peek of the building I'm talking about. So the first one is the construction. So this, I think, was the picture taken on the 30th of September last month. Yes, so it's going along very quickly and swiftly. And this is how it will look afterwards. Yes, so that is amazing. And these are the women I'll be working alongside with. So these are your previous speakers. Yes, and I'm so grateful to be part of this initiative. Yes. Yes, thank you so much. That was my journey. Thank you so much for listening.
Thank you, Nondumiso. It really is wonderful that you guys are charting a new, path in the space science, space weather career in South Africa, and we hope that there'll be more young people who will be joining you as the Space Weather Center continues and grows. So let's bring us to the end of the formal talks. I see there is a, just maybe to remind everybody about the question for today. The question for today is, when did the forecasters commence their training at SANSA Space Science in Hermanus? So if you collate all your answers to the 5 webinars that SANSA Space Science is going to give this week, and then email them at the email spacesites-info@sansa.org.za. That email address is also given in the chat box. So there is a question and it's addressed to everybody. So anyone can, any one of the focuses or all of you can answer. And the question is, how easy or hard is it to predict space weather compared to terrestrial weather? So I don't know if who wants to tackle it first. Katekile came on, so I'm guessing you want to tackle it first.
For me, I would say terrestrial weather was more simple to forecast, since it has been studied for quite a long time, and they've improved the models quite a lot as compared to space weather. It is quite new, and there's still the sun is still a bit of a mystery, so there isn't so much known about the sun. It's just people are still modeling how the sun behaves and all that. So I think it is quite harder to predict the sun than the clouds.
Okay, interesting answer there. I don't know if any of your colleagues want to jump in and add anything. If not, then I'll move on to the next set of questions. The next set of questions says, I think it's addressed to Kosinati. It reads, as a forecaster, how fast is the process to foresee an event, since it impacts so many essential instruments?
Okay, thank you for the question. How fast? Eish, that's a I don't know where to start, but the closer you get to time in forecasting in general, the closer you get to time, the more you become more accurate, and the events are different. So so far what I've learned so far with your solar flare, when you have a solar flare, it takes 8 minutes for it to reach the Earth. So you only have 8 minutes to warn people. So you can see it in 8 minutes, only in 8 minutes. With the CME, I've learned that it will take 2 to 3 days. somewhere there. So there is no, I can't say there's an exact time where we can say this is how fast you can see an event, but they try by all means to make the models to give you enough lead time. But yeah, it's not that simple. So yeah, it's just those unfortunate things.
Yeah, with interesting things, it's hard. It's very seldom that it's simple and straightforward. So the next question goes for Katekile, and it's actually it's two questions. The first part is, how frequent are solar flare to hit the Earth, given that space is so large and we are so far from it?
A solar flare travels at the speed of light, so it takes about 8 minutes for a solar flare to arrive at Earth. Yeah. For
how
the second,
they occur? Do you maybe is I think is the question like how frequent? How frequently do we see them on Earth? So not how frequently do they occur on the sun, but how frequently do we get impacted with the solar flares?
Oh, okay. Our solar activity has a 11-year cycle. So we have a solar maximum and a solar minimum. So at a solar maximum, that's where the sun is more active and you get to see more activity on the sun. So during a solar maximum, that's where you get to see most of a lot of solar flares. But during a solar minimum, very few solar flares. Okay.
Okay. The second part of the question is the models being used, do they predict future events based on the past events, or is it just observation and reporting anomalies?
I'm going to answer according to how I understand models work. For model, they feed into it previous events and also events that are occurring on a daily basis. So you can get to predict future or maybe few hours ahead based on the current observation. So you get to feed into each current observation so that you can get to see few hours ahead. I don't know if that answers the question. Okay.
Yeah, I think that's pretty much adequate. Thank you for that. And then the last question is for Boitumelo, and it reads, since some of the HF are affected by CMA, or I think it's CMEs, or solar flare interacting with the atmosphere, will it not be advisable to use those that aren't, or does the frequency vary depending on the magnitude of the solar flare energetic particles?
Okay, so with HF communication, it basically the frequencies ranges from 3 to 30 megahertz. So when you have a total radio, when you have a blackout, that's basically when you can't use any of those frequencies. So that's when you can resort to satellite communication. Some other times you get that there are some of the frequencies that are absorbed, maybe from 3 to 10, which means that you can use the higher frequencies that are not absorbed, the ones that are reflected. So I think, I'm not sure if that it's satellite communication is like being used now, but I know that it's expensive. So I don't know how frequent it actually is used.
Okay. Second question is, do you only become aware of an event potentially occurring whenever there is a dark spot on the surface of the sun?
Most definitely. I think when you have the sunspot, you start to actually monitor it, and you start to look at the complexity of the magnetic field to see if a solar flare would occur or not. But if you see that the magnetic field is like complex, you just have to continue to monitor it and to see how it evolves with time so that you can see whether a solar flare would occur or not.
Okay, great. Thank you for that answer. I think we've come to the end of the webinar. I don't see any further questions. And I would like now to thank all the ladies that have spoken today, our forecasters, that have given very interesting journey to becoming space weather focusers. And as you can see, their journeys are quite different and they have different backgrounds. So it gives you a flavor of basically the skills that are required to becoming a space weather forecaster. So maybe to close, I'd also like to again remind everybody, those who are interested in winning a goodie bag from SANSA, that the question for today is, when did the forecasters commence their training at SANSA Space Science in Hermanus? Thank you. I hope we will see you tomorrow again at 2 o'clock for our next webinar in the series. And I look forward to hosting the 2 speakers tomorrow. Thank you and have a good afternoon.